So the first thing we're going to be talking about are some vocab words that go along with this topic. So a variable is a letter or a symbol used to represent an unknown value. So when you don't know what something is equal to, we use usually a letter, and a lot of times that letter is going to be X, but it could be any letter that you choose. Another vocab word that we have is an algebraic expression. This contains numbers, operations, and variables, and it does not contain an equal sign, so there's no equal sign here. And expressions are often confused with equations, but equations do have equal signs. So an example of an expression would just be 9 minus x. An equation would be a mathematical sentence that uses an equal sign to show that two quantities are equal. So equation kind of even has that root word in it, that EQUA right at the beginning almost looks like the word equal, and that will have an equal sign. So that would be something more like 2 plus x equals 7. Now in this case, for an equation, you could solve to figure out what x needs to be. What do you need to add to 2 to get to 7? And we'll be talking about solving equations a little bit later in the year. But for right now, we're going to be focusing more on expressions, and we'll be giving you a variable to fill in for this number. We'll be giving you a number to fill in for this variable, and then you'll be able to figure out what that expression would be. So another example, or another vocab word that we would need to talk about is a real number, a variable, or a product of real numbers and variables. And that's what a term is. So when you're talking about an expression, looking back at this expression that we had, 9 minus x, 9 is a term, and x is a term, if you're looking back at this example here. So 9 was a constant, it's a constant number, and then x was our variable, and remember, term can be a real number or a variable. So right there we have a real number and a variable. Now a constant is a term that does not contain a variable. So looking back at our example that we just had, 9 minus x, the only constant there is 9. So it's a real number and it does not contain a variable. So coefficient, though, is a number that is multiplied by the variable in an algebraic expression. It is placed to the left of the variable. So something like that could be if you see 2x. If we have 2x, that's just saying that we'd be multiplying 2 times x. So 2 is actually what we call the coefficient. So just that number that is to the left of your variable is the coefficient. The last vocab word we need to look at is an exponent. And we've seen exponents before, but this is just a definition for it. It's a number that indicates how many times to multiply a number by itself. So for example, if you see something like 2 to the third power, that would mean we're doing 2 times 2 times 2. So we're multiplying 2 by itself 3 different times. The actual exponent here is the 3. It's that small number that we write above our number that's the base. So that's some important vocab that we're going to be using as we go through this topic. If you look down below at the next part of your notes, we're going to label different parts of this expression to practice this vocabulary. So the first thing we want to look for are coefficients. And remember that coefficients are the number that is to the left of the variable. So maybe the first thing we should look at is a variable. So our variable is a letter that represents an unknown. The only letters that I'm seeing here are R. So that means that R is the variable. So that's the number that we don't know, and we're using a letter to represent it for now. Now we can look for coefficients. Remember, coefficients are those numbers that are to the left of our variable. So I'm going to underline the 8 and the 2 because those numbers are both to the left of the variable that they're attached to, and they're multiplying there. So 8 and 2 are coefficients. I know it's kind of a tricky word to spell there, but there you go. Some of our other vocab words that we have terms. Remember, terms are anything that can be a real number, a number multiplied by a variable, or just a variable by itself. So we could have 8r, that's a number multiplied by a variable. We have 8 divided by 2, so that's just going to end up being a real number because 18 divided by 2 is 9. Right here, 2r times 6 is just, again, real numbers multiplied by variables. And then in our last one, we have 3 squared. 3 squared is going to end up being a constant. That's just 3 times 3, which is going to get us 9. So our constants, remember, are any numbers without a variable. So 3 squared is going to be one of our constants. Another constant, again, we're looking for things that don't have variables with them, is going to be this guy right here. So even though there's an operation going on there, 18 over 2 is just going to equal 9. So that's also going to be a constant. One other thing we want to look at is right here, this 2 on top of the 3. That's our exponent. That tells us that we're taking 3 and we're multiplying it by itself, and we know that 3 squared equals 9. So that's going to get us our 9 that's a constant. So those are just some pieces of that expression just to make you more familiar with what those words mean, because we will be using them a lot in class. So something that you also want to keep in mind for this topic are the order of the operations. So whenever we're solving an expression or simplifying a problem, we have to think about the order of operations. GEMDAS is the way we remember it. G stands for groupings. E stands for exponents. M stands for multiplication. D stands for division. A stands for addition. And S stands for subtraction. So go ahead and fill those in just as a reminder. I know you've seen this before, but it's just a good thing to keep track of. When we're using GEMDAS to simplify expressions, we always start with our groupings. So remember that groupings could be parentheses, they could be brackets, they could even be absolute value bars, which we've already seen this year. So just keep all of those in mind for groupings. Exponents would come next. So again, we kind of had an example up top here. So something like 3 squared is an example of an exponent. When you get down to multiplication and division, for multiplication and division, you want to kind of group these together, and then you're going to do them from left to right. So if you have both multiplication and division, but the division comes first in your problem, you're going to do that first. So for example, if you see 3 divided by, actually let's try 30 divided by 6, and then multiplied by 5. Before I can multiply by 5, I need to divide first because I don't know what number this is yet. So going from left to right, I would do 30 divided by 6 first. So that's just 5. And then I'd have to still multiply by 5. And 5 times 5 would get me 25. So that's what I mean by going from left to right. So if that's what you have to do first, you might have to do the division before you can multiply, even though M comes before D in GEMDAS. Same goes for addition and subtraction. You want to go from left to right. So even if you see 8 minus 2 plus 6, just do that 8 minus 2 first. Go from left to right. So 8 minus 2 is 6, and then we still have to add 6, and 6 plus 6 would get us 12. So just keep those in mind as you're going through. Always start with your groupings, move on to exponents, multiplication and division together from left to right, and then addition and subtraction together from left to right. So now that you have some of those prerequisite terms kind of refreshed in your mind, you should be ready to go, at least for starting this. So simplifying these expressions, we're going to use the order of operations, just as some good practice for how to simplify. So I want you to take a minute, remember your GEMDAS. It's on the front of your paper, but if you want to copy it down to the back now, you can. And I want you to go ahead and try to pause the video and solve these on your own. Once you've tried that, go ahead and press play and check your work. All right, now that you've tried it on your own, we're going to do this together. So the first thing in our GEMDAS, or order of operations, is grouping. So I see parentheses there. It means we're going to take care of what's in there first. So 24 minus 12, that's 12. And then all I'm doing is I only simplified that part, but I'm bringing everything else down in this. So now looking at what I have left, I have 3 plus 12 times 4. So I have addition and multiplication. No exponents are here, so we're going to do our multiplication next. So my 3 plus comes down, and 12 times 4 is 48. So now 3 plus 48 is the last thing we have to do, so our final answer becomes 51. So I want you to get in the habit of showing all of this work so you're not making mistakes and going out of order with the order of operations. Now in the next one, we have 2 sets of groupings here. So you got to start with both of these groupings. So 19 minus 23, we start with that first, and that's negative 4, but that's still over 2. We're multiplying that by what's in parentheses here, and that's 3 plus 4, so to simplify that, we get 7. So now here's one of those examples I was saying. We have to go from left to right because the only things we have left are division and multiplication. So we have to divide before we can multiply in this case. -4 divided by 2 is -2. And then we multiply by 7, and that'll get us -14 as our final answer. All right, now that you've tried some examples of how to simplify expressions, we're going to make it a little bit trickier on you. So we have these expressions where we're going to include variables, but we're going to say for this expression 2 plus 3a plus 9a, you want to evaluate it for when a is equal to 1. So all that means is we're going to rewrite this entire expression, but every place we see an a in the original one, we're going to just put in a 1 because that's what we're replacing all of the a's with. So my a and my a right here are all going to be turned into 1s. So I have 2 plus 3a, and remember, whenever we have 3 times a variable, or a letter or a number times a variable, we're just multiplying. So 3 times a, that's 3 times 1. And then we have plus 9 times a, which is 9 times 1. Now I have addition, multiplication, addition, and multiplication. So we've got to do all of our multiplication first. So we leave our 2 plus, that comes down. 3 times 1 is 3, plus 9 times 1 is 9. Now all we have to do is add these up. So 2 plus 3 is 5, and 5 plus 9 is 14. So there's our final answer. So now that I've kind of shown you how to do that, I want you to pause the video, try this one on this screen, and then you can try 3 and 4 as well, and then check your work when you're ready. So in number 2, they give us 3c plus 8 minus c minus 2 for c equals 3. So we've got to be careful here because we've got some subtraction going on. So we're replacing, every time we see a c, we're going to replace it with 3 this time. So I'm going to recopy the problem and just replace my c's with 3's. So I have 3 times c, which is going to be 3 times 3, plus 8, minus c, so that's just going to be minus 3, minus 2. That's everything that I started with, but replace the c's with 3's. So now using our order of operations, first thing we have to do is multiply. So we get 9 plus 8 minus 3 minus 2. Now the only operations we have left are addition and subtraction. So going from left to right, 9 plus 8 is 17, minus 3 minus 2, 17 minus 3 is 14, minus 2 again, and our final answer here is 12. So moving into 3 and 4, if you haven't already tried these on your own, pause the video and try them. Once you've done that, we can go through those. So for example 3, we have 9 minus z plus 3 minus 2z. And z is going to be 2 this time. So everywhere I have a z, I'm going to replace with a 2. So I start by rewriting the entire expression with the variable replaced. So 9 minus z is now 9 minus 2 plus 3 minus 2 times z, but z is 2. So now I have subtraction, addition, subtraction, and multiplication. So we need to multiply first. And we have a minus sign that's going to come down here. And 2 times 2 is 4. So really we have 3 minus 4. So I have 9 minus 2 plus 3 minus 4. So going from left to right, 9 minus 2 is 7, plus 3 minus 4. 7 plus 3 is 10. 10 minus 4 is 6. And there's your final answer. In our last example for this video, we have 3x plus 2 minus 10 minus 3x for when x equals 5. So again, all of those x's are just going to be replaced with 5's here. So we rewrite, everywhere we see an x, we put a 5 in. So I have 3 times x, which is now 3 times 5, plus 2 minus 10 minus 3 times x, which is now 3 times 5. So I need to start with my multiplication here. 3 times 5 is 15. Plus 2 minus 10 minus, and then 3 times 5 again is 15. So I have 15 plus 2 minus 10 minus 15, so I'm just going to go left to right to complete my addition and subtraction here. 15 plus 2 is 17. We subtract 10, and we subtract 15. 17 minus 10 is 7. 7 minus 15, negative 8. So our final answer here is negative 8. So just some warnings here. We always want to put our numbers in with parentheses, just in case we're ever adding a negative in there. This is going to keep our signs clear for us. We always want to make sure that we're going from left to right when we're simplifying expressions, and always follow your order of operations. Thanks for watching.